Welcome back, students. So in the last session we discussed about the Archimedes principle and its applications. We also dealt with the term relative density. Now today we are going to discuss about some force. Okay. As Archimedes mentioned, when an object is completely or partially immersed in water, the object will experience an upward force. Okay. That upward force experienced by an object when it is partially or completely immersed in a fluid is known as upthrust or the buoyant force, or simply it is known as buoyancy. Okay. So, when an object is partially or completely immersed in a fluid, that fluid will exert an upward force on that object, and that upward force experienced by the object given by the fluid is known as upthrust or buoyant force. Buoyant force or upthrust is the upward force experienced by an object which is completely or partially immersed in a fluid. Now, the concept of buoyancy explains why certain objects will float when immersed in water while others sink. All object experiences this buoyant force when immersed in water, but this floating and sinking depends on how density of a substance is compared with density of water. Depending upon the density of the substance with respect to density of water, we can say whether an object will float or an object will sink when it is immersed in fluid. Okay, that is, if density of substance is less than density of water, if the density of the substance that is immersed in water, if it is less when compared to the density of water, the substance will float. And if density of the substance which has been immersed in water is greater than the density of water, the object will sink. So, to determine whether an object will sink or float when it is immersed in water, we have to compare their density with the density of water. Then we will be able to say whether an object will sink or float. If density of substance is less than density of water, the object will float, and if density of a substance is greater than the density of water, the object will sink. Okay. Now, how? Let us see how this happens. Okay. If density of substance is more, its weight will be more. If density of substance is more, its weight will be, it will be having a greater weight. And we know that weight is equal to the gravitational force. Weight of an object and gravitational force are equal, because if this is an object, the object will always experience a downward force which is due to gravity, and we know that weight of an object is the force exerted on an object towards the center of the earth, and that force is known as gravitational force. So, and this gravitational force and weight of the object are equal. That means if density is more, the gravitational force experienced by it will be more. Now, if an object is immersed in a fluid, this object will experience a gravitational force downward due to its weight and an upthrust force. Okay. So, when an object is partially or completely immersed in a fluid, it experiences a force downward, which is the gravitational force, which is equal to the weight of the object. At the same time, it also experiences an upthrust given by this fluid. And upthrust is in upward direction. Okay. So, this is the case when an object is partially or completely immersed in a fluid. Now, coming back, if density of the substance immersed is more than water, if density of substance is more than that of water, the weight of the object will show an increase. That means gravitational force experienced by it will be more. So, if gravitational force exerted by it is more, then the upthrust felt will be less. If downward force is more, that means the upthrust felt by the object will be less. That means, so upthrust means the force which helps the body to move up, the force that helps the body to hold up, that is the upthrust. Due to upthrust, the body will float or the body will raise up, the body will come up. It is a force that holds the body or it is a force that raises the body, which holds the body up. It is a force that holds the body up. So, if downward force is more, the upward force will be lesser. Hence, since the upward force is lesser, this downward force is more. That means the object will be pulled with a greater force downward compared to the upward force. Hence, the object will sink. So, the case 1 is if density of this substance is more than that of water, the gravitational force experienced by this substance will be more. That is, this substance will have a greater downward pull than the upward pull. This substance will experience a greater downward pull than the upward pull. Hence, the object will sink. Okay. Now, the second case is if density of substance is less than density of water. Suppose we have a beaker filled with water and we are immersing an object. If this density of substance is less than that of water, if density is less, gravitational force or the weight of the object will be less. So, at the same time, this object will experience a gravitational force which is equal to weight in downward direction. At the same time, it also experiences an upthrust force in upward direction which is given by the water. Here in this case, since density is less, its weight or the gravitational force experienced in the downward direction will be less. That means upthrust experienced by it will be more. Upthrust is more. The force in upward direction is more. That means the object will float. Since the upward force is more, the object will experience an upward pull than the downward pull. Hence, the object will float. So, whether an object sink or float completely depends upon its density. Okay. If density is greater than density of water, gravitational force or gravitational pull will be more than the upthrust. Since downward pull is more, the object will sink. In the second case, if density of substance is less than density of water, its gravitational force or gravitational pull will be less compared to the upthrust. Since upthrust is more, upward pull will be more. The object experiences a greater upward pull, hence the object will float. This is how we determine whether an object sink or float in water. Now let me ask you something. We know that density of iron is greater than density of water. Okay, density of iron is greater than density of water. Then how does the ship made of iron floats on water? Why the ship is not sinking? We have already learned that if density is more, if density of a substance is more compared to water, gravitational force will be more, upthrust will be, since gravitational force is more, to balance the force, upthrust will be less, hence the object will sink. So in this case, density of substance, that is density of iron, is more. That means the ship has to sink, but it is floating in water. Why? Even though density is more, it is floating in water. Why? To understand this, or to make this simpler, let us consider another example. Okay, take a bucket filled with water. Take an empty plastic bottle. Sorry, take an empty glass bottle. Take an empty glass bottle and insert the cap airtightly. Okay, so you took a glass bottle, insert the cap airtight, and you have a bucket full of filled with water. Now try to immerse this glass bottle into the bucket filled with water. And we know that density of glass is greater than density of water. But we can observe that even though we try to immerse this empty glass bottle into this water, this empty glass bottle will float. Even though we try to immerse it, it will float. It is because the glass bottle is empty and inside the glass bottle we have air. It is filled with air, and we know that density of air is less than that of water. Density of air is less than that of water. So the overall density of bottle will get reduced since it is filled with air. The overall density of the bottle will get reduced since it is filled with air. So the overall density becomes less than the density of water, hence the glass bottle floats. Okay. So this flotation of glass bottle is similar to the flotation of ship. Even though ship is made up of iron and it is having a greater density, the ship is hollow. It is also filled with air, and we know that density of air is much less compared to density of water. So the overall density of the body of the ship will be very less compared to density of water, hence the ship floats. Okay. So the 2 points to be remembered here is, if density of a substance is greater than density of water, the object will sink. If density of substance is less than density of water, the object will float. These are the 2 points to be remembered. Now moving on to page number 142. Page number 142, you have a set of blue questions over there. In that, first question is, you find your mass to be 42 kilogram on a weighing machine. Is your mass more or less than 42 kilogram? So your weighing machine shows that your mass is 42 kilogram. Is that your true mass, or will your actual mass be less or greater than 42 kilogram? That is a question. So, when you stand on a weighing machine, when you stand on a weighing machine, our weight will act downwards. As I told earlier, when an object is there, it experiences two forces simultaneously. A downward force which is called gravitational force due to earth, and an upthrust force due to fluid. An upthrust force in the upward direction due to fluid. So, when we stand on a weighing machine, our weight, which is equal to this gravitational force, acts downwards. At the same time, the upthrust due to air will act upwards. So, when we stand on a weighing machine, our body experiences two force. One of the force acts in downward direction, which is equal to the weight of our body, and the second force experienced by our body is the upthrust due to air in the upward direction. Therefore, the net weight or the apparent weight will becomes less than the true weight. Okay, since we have two opposite forces, since we have two forces in opposite direction, the net force or the apparent force is either Fg minus upthrust or upthrust minus weight. So, apparent force or the net force experienced by the body or apparent weight, apparent force and weight is equivalent. So, apparent weight or the net weight experienced by our body will be our true weight minus upthrust. Since both the forces are in opposite direction, in order to find the total force or net force, we need to subtract it. Since both are in opposite direction, to get the net force or the total force, we need to subtract it. So, apparent force or net force, which is equal to the net weight, will be the difference between our weight and upthrust. So, our true weight minus upthrust. Okay, that means the apparent weight is always less than our true weight, because our true weight minus upthrust value is the apparent weight that we obtain. So, apparent weight obtained is always less than our true weight due to the upthrust of air. Okay. So, since weight is less, the mass will be also less. So, our true mass will be less than 42 kilogram. The mass shown by the machine will be less than our true mass. Okay. So, the answer is, when we stand on a machine, our weight is acting downwards, which is equal to gravitational force. At the same time, we are standing in air. So, the air will exert an upward force called upthrust. Since both the forces are in opposite direction, to calculate the total force, we need to subtract it. So, net force or net weight is our true weight minus upthrust. So, from our true weight, upthrust is subtracted. So, our true weight, so apparent weight or the net weight will be always less than the true weight of our body, because we are subtracting upthrust from our true weight to get the apparent weight. Since apparent weight is less than the true weight, apparent weight is the weight measured by the machine. This is the weight measured by the machine. Since apparent weight is less, the mass shown by machine will also less than the true mass. The mass shown by the machine will be also less than the true mass since the apparent weight is less. Hope it is clear. Now, moving on to second question. You have a bag of cotton and an iron bar, each indicating a mass of 100 kilogram when measured in a weighing machine. So, both cotton and iron is having a mass of 100 kilogram, equal mass. In reality, one is heavier than the other. Can you say which one is heavier and why? Even though they have equal masses, one is heavier, one substance is heavier than the other substance. Now, which substance is heavier and why? That is the question. You will be having different answers. Some will say iron, some will say cotton. I need which is heavier. Right. Cotton of mass 100 kilogram will be heavier than the iron. Will you agree? Will you agree? Why? Because, listen, my answer is cotton is heavier than the iron of mass 100 kilogram. Why? Because 100 kilogram cotton will have more volume. So, volume of cotton will be more than volume of iron. Since cotton is fluffy, the volume of 100 kilogram cotton will be greater than 100 kilogram iron. Since volume is more, what about its density? Density of cotton, we know that density is mass by volume. So, if volume is more, density of cotton will be less. Density of cotton will be less. Density of cotton will be less than density of iron. Okay? That is the true weight. That is, if this is cotton, the cotton will experience two forces simultaneously, and a gravitational force which is equal to its weight acting in downward direction, and an upthrust force acting in upward direction. Since density of cotton is less, this gravitational force will be less. The gravitational force acting downward will be less, and this upthrust due to air will be more. So, true weight of cotton can be calculated as its weight plus the upthrust due to air in upward direction. This is how we calculate the true weight of a cotton. Its weight plus an upward force given by air. So, since its density is less, it will experience an upward force. So, its true weight, its weight can be calculated as the weight of cotton plus the upthrust. Since an upthrust is added to its weight, its true weight becomes more than that of iron. Okay. So, that is all about the true weight and the apparent weight. Hope the concept of buoyancy and flotation and sinking is clear for everyone. Thank you.